Good morning, YouTube. Today we will be learning about uh, total curvature and curvature of average curvature of an arc and curvature at a point and also radius of curvature of an arc. So firstly, to start with this video, we should know about what actually the curvature means. So the curvature gives a numerical measure of the sharpness of bending of a curve. It basically gives a numerical measure. Basically gives a numerical measure. Okay, numerical measure of sharpness of bending of a curve. Bending of a curve. This is your curvature. Okay, so it gives a numerical measure of how sharp is the bending of a curve is. Okay, so let us start with this. Let us suppose there is an arc. Let us make an arc first. Suppose this is an arc. Let us take a reference point A here, from which we will calculate the arc length. Let us take a point P here and a point Q here. Okay, we have taken these points such as the arc length of AP here is S and the arc length of AQ is S plus del S, and arc length of AQ is S plus del S. So the arc length of PQ will become delta S. Now take a tangent at the point P here. Take a tangent at a point P here. Suppose it makes an angle psi with the initial line. Suppose this is the initial line OX over here. This is the initial line, and the tangent at the point P makes an angle of psi with the initial line, and the tangent at the point Q makes an angle psi plus del psi. As I have taken the values here S plus del psi, so the angle is S plus del S, so the angle is psi plus del psi. So if this angle is psi, this angle is S plus del psi, then what is this angle? How much is this angle? If we apply the property of a triangle that the exterior angles is equal to the sum of the opposite interior angles, so we will get this angle as del psi, because the exterior angle is equal to the sum of the interior opposite angles. Okay, so this is angle over here is del psi. Now take this point as T, this point as T dash. Then what is this angle? What is this angle T dash? What is this angle? This is the angle known as the total curvature. Now what total curvature is? The total curvature is the angle through which a tangent turns as a point moves along the curve from P to Q. Okay, del psi here is the angle through which this tangent turns as a point moves along the curve from P to Q through a distance of del S. Okay, so this angle del psi is the total curvature. Now then, if this is the total curvature, then this ratio del psi over the arc length, the angle through which the tangent turns, and the length which the tangent covers, this ratio is known as the average curvature of the arc PQ. Okay. Now, what is curvature at a point? At a point, say P. So curvature at a point P means limit point Q tends to point P. It means this point Q over here is nothing but the point P itself. So since the point P and that point Q tends to P, then the delta S will tend to 0. So limit Q tends to P, the ratio of the angle to the ratio of the length. This is known as the curvature at a point. If we solve this, if limit Q tends to P, then delta S tends to 0, then limit this is equal to limit delta S tends to 0 del psi by del S. This is delta. Okay. Now if delta S tends to 0, then this thing becomes equal to d phi by ds. This is small delta, very small change. Sorry, this is delta, big change, and this is small change. This is a very small change. This is a relatively bigger change. Okay. So d phi by ds is the curvature at a point. Now what is radius of curvature? It is the reciprocal of curvature at a point. Which is equal to ds over d psi. Thank you. Now, if you want more videos like this on engineering mathematics, don't forget to subscribe the channel and also comment the topic below on which you want to make me on which you want me to make a video upon. Thank you.